So in this problem, we're given circle K, and angle AKE is 60 degrees. AT and TE are equal in length, and HT is 8. And the area of sector AKE is 24 pi. We want to determine the exact area of quadrilateral KATE. Okay, we're going to start with the sector. The sector is a piece of the circle. Now they told us that angle AKE is 60 degrees. Now, an entire circle represents 360 degrees. This is only a piece of it. So what we've got is we've got a proportion. Part to whole equals part of the area to the whole area. So that means if we want to figure out the entire area of the circle, we would just cross multiply and divide. And so the area, when we multiply 360 times 24 and divide by 60, we get 144 pi. Now that's equal to pi r squared. So that means the radius of this circle equals 12. All right, so let's draw a picture now. So we got 12, 12. This has a length of 8. This has a length of 12. Now, we want to figure out the exact area of this quadrilateral, and we don't have enough information yet. Because what this quadrilateral is really two triangles, one up here, one down here. They're identical, but that's how we're going to find the area. Now, like all triangles, you need base and height. We know the base is 20, but we don't know the height. How do we figure that out? Well, if we connect these two, what is this angle? Well, again, it's 60 degrees. What are these two angles? Well, this is isosceles. So that means these two have to be the same. They have to be 60 as well because they add up to 180. Well, since these are all 60 degrees, this is an equilateral triangle. So that means the length from here to here is the same as the length from here to here and so on. So this is 12. So if I look at one of these triangles, I get 20 and 6. So the area of this triangle is 1/2 the base times the height. So this triangle has an area of 60, but this quadrilateral KATE is made up of two of these. This one up here and this one down here. So we're going to double it. So we get a total area of 120. And there's our answer. And we're done.